campaign on Instagram, and we can do a couple of things with it. We can do sentiment analysis, so understanding whether or not the words are positive or negative. Are these good things or bad things that people are saying? And getting a sense of that. Think about how valuable that is, right? To a marketing team who's running a brand new campaign, they have no idea if people like it or not, they're just paying millions of dollars to run this campaign. Now we know because we can run a machine learning model to understand the sentiment. We can also find comments that are similar so that we can market to the people making those comments with things that they might like based on like the type of person that they are. We can do things like that. I want to give you an example of natural language processing that I actually worked on. I think I talked to some of you guys about this earlier, but it was actually in a hospital. And so what happened was in the ICU, a lot of times doctors and nurses will take a lot of notes when they go to see a patient. And if you're familiar with an ICU, usually those people in the ICU are fairly sick. So doctors and nurses are always going in. If you know any doctors and nurses, you also know that they work really long shifts and they have lots and lots of patients. So it's hard for them to go and read all of these notes all the time. So what we did was build a natural language processing model that actually took all of those free text notes and created topics. And basically what those topics were saying, hey, out of all of these notes, this is what this note is actually about. This note is about their pulmonary responses. This note is about their cardiovascular problems. This note is about dinner and what they did. This note is about, if they went for a walk today, if they could get out of bed, things like that. And we used those topics to actually feed another machine learning model that was predicting the probability, so between 0 and 1, of somebody having a critical event. So maybe getting even sicker in the next hour or 2 hours or 3 hours. So doctors can now come in and instead of reading all of these notes, just look at that single number score. So think about all the time that's saved by them just seeing that prediction. 95% chance something bad is going to happen in the next hour. I need to take care of this patient now. Versus 5% chance of something bad happening in the next hour, they're probably going to be okay. The next one is recommendation engine. So this one should probably feel a lot more familiar to you guys. So if anyone uses Netflix, Pandora, like Google searches, when you start typing and it recommends and you're like, how'd you know? Yeah, I was gonna totally Google that. How do they do those things? Those are recommendation engines. So recommendation engines are basically machine learning models that try and predict what somebody's going to want or like without actually asking them. So for Spotify to come to you and be like, hey, do you like this song? What about this song? What about this song? Do you want to listen to this song next? What about this song? No one likes that. No one wants that. That's a really bad design, right? So instead, is there a way for us to use what we do know about you? Songs you've listened to before, things that you like and dislike that you've clicked on. Can we use those things to just guess, educated guess with a really big machine learning model to guess what you're going to want to do next? That's where you get the, because you watched this, you should watch this. Because you like this song, you should try this song. All of your daily mixes on Spotify, those are all coming from machine learning models. One of the recommendation engines that I actually built was for a event marketing website. And so basically what they did was they had all these events in Richmond, and you would subscribe and you'd say, and we'd pull all of your data from Facebook, and we'd say, okay, they went to these 10 events. Because of that, the recommendation engine is going to recommend these other 5 events for you. And we'd actually send those out in an email every Friday. I actually subscribed to this. After I built it, I decided to become a user because otherwise that's pretty great. And the emails were great. I went to a bunch of concerts. I did all this cool stuff because of a model that I had built. I got to actually see it live. It was recommending all these really cool events that I wouldn't have known about, but it knew that I would enjoy because of things that I had done in the past. Okay. So now that I've been talking at you for a while, I wanted to ask you guys. So after hearing about some of these different applications of machine learning that I've worked in, can you guys think of anything else in your, I know I've probably chosen a lot of the ones that you guys would have picked, but can you think of anything else where machine learning might be present in your life today? No? Don't make me. No? Yeah. Google. Yeah, no, for sure. So smart, AI, so it's smart homes and like your Alexas and your Google Homes, all of those things are driven by artificial intelligence, machine learning, like understanding those conversations, like those are all stemming from models. That's exactly right. And those things make recommendations as well, right? My Alexa knows more about me than I know about myself. She's like, do you really want the lights off right now? I'm like, you know what, you're right. I don't, like, leave them on. And she does. But that's because it was different than what I usually want, right? So there's models that understand anomalies. So I think I talked to some of you guys about this before. Anomaly detection. I tell Alexa to turn my lights on every morning at 6 a.m. If I don't tell her to do that, she's like, Ashley, are you up? Like, you want your lights on, right, at 6 a.m.? Because it's an anomaly for me not to. Anomaly detection is a whole branch of machine learning. We were talking about it earlier with credit cards. If you've ever gone and tried to use your credit card and it gets denied, maybe you're in like a different state or you're in a store you've never been to, or you try and order bathing suits from China, which I do off Instagram. And Bank of America doesn't like when I do that because it's like, you never shop in China. That's strange. That must not be you. That's fraud. That's a model. That's anomaly detection. We're looking for things that stick out, that don't make sense. Does anyone else have any other ideas? Yeah. YouTube? Yeah, so like recommended videos and stuff like that? Absolutely, yeah. So there's actually a couple of things with YouTube. So recommended videos, absolutely, like on the side, like other videos like this, that's definitely model driven. And the other thing is actually all of the ads that get shown to you on YouTube. If you've ever noticed, a lot of them seem like very creepily related to your life. It's because there's models in the background that are running that have watched your activity in other parts of the internet that say, oh, she really likes shopping at Loft. Like, I'm going to show her a Loft ad. Or she's been talking about hiking boots. This just happened the other day. I told some of you guys about this before. In front of her Alexa, I'm going to give her an ad for hiking boots before her YouTube video. That's also machine learning driven. Yeah.
Location data from Google Maps.
Yeah, so absolutely. So that's like an awesome example of just like the amount of data that we have. So like your location on Google Maps, so Google actually uses your location to feed its recommendations for its search bar. So if you've ever noticed, if you're out in your car and you Google pizza, they will usually recommend pizza places like right near you. But when you're at your home and they know it's your home because it's probably labeled in Google that you're home, it's not going to recommend pizza places over wherever you were in your car. That's all of this data that's coming in that they're now able to use to make more personalized experiences everywhere you go, right? I mean, it's really fascinating. I mean, Googling the same thing in different places at different times of day will give you completely different results because it's driven by this personalized experience that everybody wants now that's driven by data. Yeah. Sure. Your location. That's a really great question. So she was asking if you guys can hear it, like if you Google something and Google asks like, can we use your location? And you can say yes or no, like what happens once you have that. So I don't work at Google, so like don't quote me because it might not be true. But I know, I do have a couple friends that work for Apple, and Apple also has maps, and I do know there. So they use that for a time, but they don't actually keep it forever. So a lot of things, we were, I think, talking about this in one of the classes earlier, a lot of data that you do, things that you do online get stored for use later, or like companies will sell data about you to another company so they can market to you in a more personalized way. Location's a little tricky because we've got laws around like what we can and can't know and keep about you forever. So a lot of those things are very short-lived. So they actually use them to create a personalized experience in that moment. But a year later, they wouldn't know that that's where you were in that moment. And if they do, a lot of times there's security around being able to chain those events together. So like we'll know somebody was there and that was attached to your account when we were doing that search, but we won't know that it was you a year later. So we'll be able to actually connect to those points. Yeah. Got a little bit more. Cool. Okay, so you want to make machines learn things. Awesome. So how do you do that? So I think the thing that I love most about my job is that I when I was in high school, didn't know what I wanted, right? Like, am I a doctor? Am I a lawyer? Am I an actuary? Am I a teacher? Am I a stay-at-home mom? Am I like taking care of puppies? Like opening my own dog walking business? Like, I don't know. And I basically got to like astronaut maybe? Like, who's to say? And I've basically gotten to do every single one of those things with my skill set from my computer science and my math degrees. I've gotten to work at NASA and do supersonic system analysis using IBM Watson's, like, I don't know if you guys know Watson, the robot that won Jeopardy. Like, I worked with the Watson team at NASA to do supersonic systems analysis and NLP on accident reports. It was awesome. I never would get to work for NASA if I didn't have my math and science skills, even though I don't have like aerospace skills, right? I got to work in education even though I don't have a teaching degree because I got to build a competency-based education on an iPad so that people can get degrees faster. That was awesome. I got to work in healthcare and help that hospital, even though I'm certainly not qualified to be a doctor or draw blood or like put band-aids on people. I got to do all of these things because of my skills. And I got to meet a lot of really awesome different people. So one of my coworkers has his PhD in psychology. Another one of my coworkers has a master's degree in biochem, spent years doing neonatal renal failure research in a NICU. One of my other coworkers actually didn't go to college. Don't let any of the adults hear this. He didn't actually even go to college. He was a sponsored skateboarder for a time and is now like the best front-end developer that we have. We have the coolest team of people because everyone has different interests, but we all have this similar skill set of being able to write code and build models. So I think that that's absolutely my favorite part. So like if you want to do this, machine learning, right, it's have those foundations in math and computer science because those will help you grow your skills, but also just go somewhere where you're interested in what you're doing. So if you love education, like go be a front-end developer for an online, like college. Go, if you like really love healthcare, maybe build models to understand like the gene patterns in different diseases. It's all the same skills, right? But in different industries. And what makes you valuable on teams like that is your passion for whatever it is that you're working on. Don't tell Capital One, not super passionate about credit cards, but it is really interesting and finance is really important and it drives literally everything else in the world, right? Because money drives lots of things. So I've gotten to see a lot of cool things because I've been working in banking. So want to make machines learn things, take a couple classes in computer science, understand some math, and then just like go find something that you love and ask lots and lots and lots of questions. I didn't know that I was even doing machine learning when I started doing it, and it became now what I do every day, which is super cool. And with that, questions. This is my dog, the dog walking business. That's the inspiration behind this. This is as close as I got. Does anyone have any questions for me about machine learning, my life? Yeah.
What's your favorite model?
Oh, that's such a good question. My favorite model that I've worked on. Interesting. So, this is going to sound so lame, but that's okay. Oh no, actually, okay, there was a really cool model. A lot of you probably already heard about this, but I'm telling you anyway. So we built a model that when people post pictures on Instagram, there's types of models that can like specifically analyze images. That's what they're used for. So they break images into pixels, and then you understand relationships, things like that. And you can model things about pictures. So you can like say the common example is this a dog or a cat? That's like that's like how you learn how to build these models. You show a picture of a dog, and it says it's a dog. You say it's a cat, it shows cat. So people really get really excited about spending money, and so a lot of times people will post pictures of their brand new credit cards, or like, have you ever seen like people posting like their social security cards and like passports on Instagram? Like, what are you doing? But credit cards specifically or checks, they cause a lot of like fraud problems for the bank, which costs banks a lot of money when there's fraud because then we have bad transactions that we have to go back and deal with. And so what we did was we built a model that could pick out Instagram and Twitter pictures that were of credit cards from our bank. And so instead of waiting for that person to undoubtedly have someone spend thousands and thousands of dollars on this credit card that they're so excited about because they put a picture of it and the number, on Instagram or Twitter, we would find them, report them like instantly to Twitter or Instagram, and they would take them down. So it was a way for us to stop fraud. Besides that, I think my most feel-good model, I was working for a startup in the ed tech space, and we were building competency-based education on an iPad. If you guys don't know what competency-based education is, neither did I, but it's basically like, say you got like a degree in chem or something, and then you like somehow got a job in accounting. And you've been doing accounting for 15 years, you're like the best accountant they have, but you don't have an accounting degree, and you really want to bring your career to the next level, and you really want this degree. So a competency-based platform would basically allow you to do this at your pace and like test out of things that you already knew. So what I actually did was build the adaptive learning models that not only like customized the way that you learned. So like if we recognized after a while that you were much better after watching videos, we'd show you more videos. If you were much better as like a visual learner, videos, audio learner, we'd like recommend more of the audio resources, things like that. And then also just the adaptive nature of it. So finding the best path for you to get through this course as quickly as possible, and that was all customized to the person. So it was really cool because not only did people get to get degrees they really wanted and maybe couldn't afford otherwise, but they got to do them faster and for less money. And so it just made education a lot more accessible to a lot more people, and that felt really good. Any other questions? Is anyone like a junior or a senior? Is anyone planning on going into computer science, like in school, in college? Are you kidding? Isn't this like the computer science class?
They're afraid you're going to ask.
I'm not going to ask you questions. Be like, come up here and code something. No, I wouldn't do that. Well, I would recommend, even if you're not planning on doing computer science in college or in high school, I would recommend that everyone just take a class. Like take a free class online in like Python, do something small, do something like not too hard, just on your own computer on your own time, and just like see what it feels like to build something. If you like puzzles, if you like solving problems, like writing, there's nothing better than writing code that works. Just like go try it and see. Even if you only took like 2 classes, one, it's great for the job market because everyone loves the person who can write some Python scripts. That's actually true, I'm not kidding. But like you might actually love it. Yeah. Like a machine learning model? Like what are they? That's a really good question. Yeah, so I just like talk about this and I'm like expecting you guys to know what I'm talking about, which is so unreasonable. So machine learning models, like there's tons of different types of machine learning models, and they all look different depending on the type of model that it is. But the very like basic low-level answer to that question is it's just a bunch of mathematical models, of mathematical equations, right? So at a very basic level, let's say we were building a model to predict your weight based on just knowing your height. Don't do this, it doesn't go well. So maybe you have a model that says your height times 10 is your weight. That's a model. That's an equation, right? That's like a very basic model, but it's called a linear regression model. That's what it's called. So you can just sound like really fancy now when you say that. And so what we do is we start building these models with more and more features. So we expand on that model to make it more specific. Maybe we take in your height and your, I don't know, your like waist measurement and your neck measurement and like your hat size. And we say, 10 times your hat size plus half of your height plus 2/3. We train the model to figure out what those numbers are. And we say, okay, now this predicts your weight and it's better, it's more accurate, we're closer, we have a smaller error. And it's just another equation. So when the models get more complicated, obviously the math gets much bigger. A lot of times there's lots of doing the math over and over and over again until we get to a solution. But at the basis, that's really all it is. So depending on if you write a model in Python, just a bunch of Python code, you can package them up in different ways. There's tons of different ways to actually use the models, but at the basis, it's just math. Yeah. Anything else? Any questions? Yeah.
Can you talk about how machine learning works with the
What the computer is doing?
Yeah, so when you feed a data set,
Yeah.
what is the computer doing?
so like what a model training looks like, kind of, sure. I was like, I am not a computer engineer, so I don't know what the computer's doing. I leave that to somebody else. But yeah, so basically what happens is, let's say we were building that model, that linear regression model that we were just talking about, and we want to learn how to predict your weight based off of those things, right? We have your height, we have your waist, we maybe have your hat size, and like your shirt size. Okay, so now we have a bunch of data that we've already collected. So maybe we have 1,000 people. That's not actually that many people, but 1,000 people, and all of their measurements, and then their height and their weight. So we feed that all into the computer, and the computer optimizes what those numbers are in between each of those features, for each of those features. So maybe it's your height times 3, and your hat size times 2, and it puts those all together into an equation that gets the difference between your real weight and the weight we're predicting to be the smallest amount possible, right? We want a model that gets as close as possible to the actual number that we have. So it does that, and then we get a final model, and then we can use it on people that we don't know their weight. We just predict it, right? We don't actually know. We get to use that model later on data that we don't have the answer to. And that's really the whole point. It's take data that we have, learn something from it, and then apply it to things that we don't know, and hope that it's as close as the data that we did know. Sometimes it's not. And that's okay. Anything else? Yeah.
Good afternoon, Tigers. This is your senior class vice president, Courtney Bailey, and I'm here with Kaya Fox, your SBA secretary. And these are your afternoon announcements. Are you looking for community service hours? Volunteer in the attendance office. Volunteers are needed throughout the day, including before school. See Mrs. Martino for more information and get those community service hours in. Students, you can register to vote on Friday, April 26th